Alright, welcome to Unit 4 test review. Let's start with number 1. Determine the measure of arc MN. In circle T, given the measure of angle MTN is equal to the measure of angle SQR. And I made that correction here. Well, we know that angle SQR intercepts a semicircle. So here's that semicircle here. And we know that that semicircle has a measure of 180 degrees. Well, SQR should be half of that. It's an inscribed angle, so it measures 90 degrees. And therefore, if this measures 90 degrees, then this angle here also measures 90 degrees. And being this is a central angle, we know that the measure of the arc MN that's intercepted here, I'll go ahead and draw that in a different color for you. MN, we know that its measure is the same as its central angle, 90 degrees. So the measure of arc MN is 90 degrees. What's the measure of angle BCD? And that's on number 2. Well, we have angle BCD actually intercepts, that angle here, intercepts a semicircle. And its vertex C, is on the circle. Therefore, from one of our theorems, we know that this angle here is measured half of its intercepted arc. Well, its intercepted arc measures 180 degrees, so the measure of angle BCD must be equal to half that, which is 90 degrees. It is a right angle. Find the value of x. Well, we know that this inscribed angle measures 17 degrees. We know that an angle inscribed in a circle measures half its intercepted arc, so x must be equal to 2 times 17 degrees, which is therefore 34 degrees. Again, an inscribed angle measures half its intercepted arc, so we doubled the inscribed angle to get the arc. Let's go on down. Number 4, what's the measure of angle VXY? We have angle VXY here. Well, I don't know that we're going to be able to use the information given. We have 2 arcs, arc VW and the measure of arc YZ, but we could use those arcs to possibly get this angle here, VXW, and then use our linear pair theorem or rule that we have and make an assessment on the measure of angle VXY from there. So we know this angle here is 1/2 the sum of its intercepted arcs, or at least the intercepted arcs from these 2 secants. And so let's add those 2 arcs together, and then we'll divide them by 2. 55 plus 25, that's 80, so we get 1/2 of 80. That equals 40. So we know that this angle here is 40 degrees. Well, if this angle is 40, it sits on a line with angle VXY, so that's a linear pair, so we can do 180 degrees minus 40 degrees. And that is going to give us 140 degrees. So that's the measure of angle VXY. Well, it measures 140 degrees. Let's move on to number 5. If segment WX is 4 inches, so we've got 4 inches here, and we know that YZ here is 6 inches. Well, what is the length of WY? Well, we can use one of our segment theorems that we have with circles. And we've got a tangent here, so we're going to square this outside part and set it equal to the outside times the whole. The outside times the whole here. So we've got 4, and I'm going to call this x. And then obviously we have 6 plus x here for the whole. So 4 squared equals x times 6 plus x. Well, we've got to do some distribution here. So you get 16 equals 6x plus x squared. And what I would do here is go ahead and subtract 16 from both sides, and you get 0 equals x squared plus 6x minus 16. Well, go back and look at some factoring rules we've used in the past, but you should be able to factor this pretty easily. What factors of negative 16 would give you 6? I think very quickly you're going to get 8 and what, a negative 2, right? So minus 2. We've got 2 solutions. If you set this equal to 0, you know that x could equal negative 8 or x could equal 2. Well, the thing is we're looking at a length here. We're looking at a length. Our length cannot be negative, at least in this case. X cannot equal negative 8. So our x must be equal to 2. We need a positive length here. So what's the measure, or what's the length of segment WY? Well, it must be 2 inches, okay? And you can plug that back in and double check in our formula. Number 6, what's the measure of angle CAB if we know arc BC measures 62 degrees? Well, this measures 62 degrees, and we're looking for angle CAB. That's an inscribed angle. Just to trace that for you, that's this angle right here. It's inscribed, so we know that this angle must be half its intercepted arc. We take a half of 62 degrees, and obviously the measure we're going to get there is 31. So what's the measure of angle CAB? Well, it's going to be 31 degrees. Let's scroll on down. So if YZ equals 100, so we know YZ is 100 degrees, and we know that VW, arc VW, measures 30 degrees. We're asked to find the measure of angle YXZ, so this angle right here. Well, basically we've got two chords, or we got two secants, but we could think about it as two chords that intercept these two arcs. We're looking at an angle inside the circle. Well, that angle, I'm just going to call it, well, we'll say measure of angle YXZ. It's going to be 1/2 the sum. It's essentially the average of the two angles. So 100 degrees plus 30 degrees. Well, that's 130. Half of 130 should be 65 degrees. That angle measures 65 degrees, a half the sum of the intercepted arcs. What's the measure of segment DH? So we're looking, we'll just call it X. We're trying to find DH here. Well, when you have two chords that intersect each other inside a circle, we know that we can do part times part. So we can do 6 times 6 equals part, I'll just underline here, part times part, 3x. 6 times 6 is 36, equal to 3x. Divide both sides by 3, and we know that x now equals 12. So what's the measure of segment DH? It measures 12 units. Find the value of x. Well, we know that this angle here is a right angle. So this angle measures 90 degrees. But it measures half its intercepted arc. So 90 degrees equals 1/2 4x plus 8. By the way, that's degrees. We'll take half of all of that. So we get 90 degrees equals, what is that, 2x plus 8. Excuse me, 2x plus 4. And that's degrees. This is all going to be measured in degrees here. So that's, we'll put a degree symbol there, and whatever number we get for x will also be measured in degrees. Subtract 4 from both sides. We have 2x equal to 86 degrees. And divide by 2. X equals 43 degrees. Okay, and I'll go ahead and make that a little bit more clear for you. X equals 43 degrees. In preparation for your test, make sure you're up on your algebra skills. Okay, you're going to need those a lot for this particular test in geometry. Find the measure of segment WS and WQ. So again, we've got two chords that intersect inside a circle, so we're going to do part times part equals part times part. So we're going to do 8 times 9, which is 72, equals 6x times 12x. So we've got 72 equals, well, 6 times 12, that's 72x squared. We'll divide both sides by 72. 72's cancel, we're left with 1 on this side. Over here we cancel, we're left with 1x squared. So we have 1 equals x squared. Take the square root of both sides. X equals 1. Okay, x equals 1 in this case. If BF equals 9, so from B to F, 9 units, and CB is 3, so we've got C to B here, 3, and find CA, excuse me, so we need to find CA. We're trying to find this, we'll just call it X here, it's an unknown. Well, what we can do is outside squared, or the tangent squared, equals the outside times the whole, which would be 3, times the whole would be 3 plus 9, which is, of course, going to be 12. So x squared equals 3 times 12, which is 36. Take the square root, both sides, I guess I should have marked that over here. We took the square root of both sides. And x equals plus or minus 6, but we're going to, in this case, x is the full length here. We're just going to use the answer, positive answer 6. So what does CA equal? CA equals 6 units. Number 12, find the value of x and y. Show all work. Give me one moment. Needed to check our time there. So find the value of x and y. Show all work. Round to the nearest tenth. Well, we've got a quadrilateral inscribed inside a circle. So we're going to try to do some math here. One thing that you probably have carried over from your previous unit is that inside quadrilaterals, opposite angles here are supplementary. So we've got 90 degrees plus 3x equals 180 degrees. Subtract 90 degrees from both sides, you have 3x equals 90 degrees. So x, go ahead and clean that up real quick, x equals 30 degrees. We'll go ahead and get rid of this for a second. So 30 degrees. So now let's look at y. So those two angles will add up to 180 degrees. You can think about it this way too. They're both inscribed angles. And so the sum of these two inscribed angles would be half the complete circle, which would be 180 degrees. So 2y minus 3 plus y plus 5 equals 180. We're going to solve for y here. So we have 3y plus 2 equals 180 degrees. So we'll go ahead and make that an 8 there. You could probably tell what I was thinking. We need to subtract 2 from both sides. So 3y equals 178 degrees. And then, of course, you could use a calculator really quickly. I'm going to pull up my calculator here. And 178 divided by 3 says that's 59.3 repeating. So it says round to the nearest tenth. So y equals 59.3 degrees. Plug those back in, and you can add all those angles up. They should add up to 360 degrees. I believe we still have a few more moments here. Yep, we've got about 2.5 minutes. Let's see how many more we can complete. Let's see, number 13. If the measure of arc ML is 175 degrees and the measure of arc ON is 15 degrees, what is the measure of angle MPL? So we're trying to find this angle here. It's outside the circle. Outside the circle, you take the difference of the two arcs and divide by 2. So 1/2 175 minus 15. Well, that's going to be 1/2 160 degrees. So that would be 1/2 160, which is 80 degrees. So what's the measure of that angle? Well, it's 80 degrees. Let's move on to number 14. Find the area of the shaded sector. Well, the shaded sector has a central angle of 170 degrees. So if we wanted to find that area of that sector, well, we would have to take 170 degrees, of course, divided by 360 degrees, and use our area formula. So times pi times r, 7, that's our radius, squared. Okay, I'll let you type that one in the calculator. I'll go ahead and put it in here as well. We've got 170 divided by 360. That's 0.472 repeating. Let's see, times pi, so times 3.14159. I'll use that as an estimate for pi. And then times 7 squared. Well, 7 squared is 49. So I've got an estimate, if we round this guy off, to 72.69. So this is approximately, see if we can get approximately here. There we go. Approximately 72.69. What is that? Centimeters squared. Let's see if we can get that there. Squared. Find the arc length of arc ABC. So they want this major arc here in green. Okay. Trying to read this here. My copy's not very good. I don't think I have a copy here. Actually, I do. Let's see if I'll try to double click that and see if we can see that a little bit better. 10 pi over 7. Okay. So when I imported, it was a little blurry. So this is 10 pi over 7. And my radius is 5 centimeters. So what's that arc length? Well, that arc length, of